There's no denying the planet is certainly changing, global warming or climate change, whatever term you use. Dr. David Sanborn Scott, in his new book, The Smelling Land, The Hydrogen Defense Against Climate Catastrophe. The book has been hailed by experts, and of course now we've invited Dr. Scott on the program to give us the background behind his theory of hydrogen as the only solution to the climate catastrophe. Dr. Scott, welcome out of the fog. Thanks for coming in, sir.
Thank you very much, and it's a great title for your program.
Well, we appreciate that, and great title for the book, just to pay back. Dr. Scott, it's a fairly complicated matter when we talk about global warming or any solutions for it, so let's break it down to the bare bones at the beginning. How do we get at hydrogen? What is it in its most basic form?
Well, hydrogen, of course, is the simplest element of the universe, and there's more hydrogen than anything else. And if you're talking about how we use it as a fuel, which we'll be talking about, you have to do two things. You have to have a material from which you can mine hydrogen and an energy source to do the mining. And the obvious way is to mine it from water, because water, as you know, is made out of hydrogen and oxygen. And probably the way that most people know about it is from high school, when the teacher had to split water with electrolysis and some kid wanted to make a pop, do you know what I mean, and make it go bang. So that's, I think, how we would be introduced to how hydrogen is a fundamental element, at least of water. There are many other ways to make hydrogen, but it's commonly used. We make a lot more hydrogen in Canada for heavy oils and a lot of other things than we do make beer, so that gives you a context.
So when you talk about something so fundamental and abundant, how is it, in a nutshell, and we'll try and elaborate as we go on here, how is it the only answer to the climate catastrophe, as you put it?
Well, I didn't say it's the only answer. What I said was it's an absolutely essential answer. Okay. And I think the thing that is troubling me is that people are missing the importance of it. And the reason it's so critically important is that if we're going to beat this climate catastrophe, we have to have non-fossil, non-CO2 emitting sources do everything. In other words, in the end, it'll take time, we have to have no CO2. Well, we can do that for electricity now. In other words, we can use hydraulic to make electricity, or nuclear power, or wind, or whatever. But how do you get a windmill to fly an airplane? See? So that's the issue. And the issue then is that you do what nature does, because nature splits water to make hydrogen, to make tomatoes and all the rest of it, which is how our planet stays alive. And we will use non-fossil energy. Nature uses the sun. We'll sometimes use the sun. We'll use nuclear and hydraulic to split water to make hydrogen, and that'll fly our airplanes and drive our cars and that sort of thing. By the way, it'll also do other things, because we need chemical commodities, and so it goes into margarine and that sort of thing. You
point directly at transportation as being one of certainly the biggest polluters and the worst causers of carbon going into the atmosphere. And then, of course, nobody ever talks about that as a way to solve the global warming phenomenon. So it just seems so fundamental, but yet I've never heard of this explanation until I had a look at your work.
Well, it seems terribly fundamental to me, and to me it's terribly simple. And that's why it troubles me that the world seems to be missing it. You're quite right that nearly all the solutions that we have out today, which are not full solutions, they're saying, well, let's use non-fossil energy to generate electricity. The obsession is with energy, with electricity. And people are missing this really important need to get at the transportation sector. And the transportation sector is critical, and that's what we're missing, except for Band-Aid solutions, like let's have a Prius, you know what I mean, which uses a little less gasoline or things like that. But that's not going to solve it. We really need to have a whap at it, a big one, and that means we have to move to hydrogen. By the way, I'll just throw in something else. We've started. In other words, we flew to the moon on hydrogen, and only hydrogen could get us there, because hydrogen is so light. I don't know if you know this, but hydrogen, for energy content, is about a third the weight of gasoline. So we'll gradually move to it.
Is the technology, like you say, we flew to the moon, but that's one thing, but can you have it practically in the planes of today, in the cars of today? And another thing people are very worried about when they think hydrogen, is it safe? Because the first thing that comes to mind is the Hindenburg influence.
Yeah, well, which do you want me to ask?
No, you can address those both.
Let me do the safety one first, because you're quite right. The Hindenburg accident, in other words, every time you talk Hindenburg, somebody puts that shot on of the Hindenburg coming down. The curious thing is that hydrogen had nothing to do with the Hindenburg accident, which went on for years. And then Addison Bain, who I've come to be a friend of, he was in charge of propellant procurement for NASA for years, and he felt that hydrogen was really safe to work with, because that's, as I say, what they flew with the moon with. Then he looked into what really brought the Hindenburg down, and they coated the surface of the Hindenburg fabric so it would reflect sunlight with a chemical composition which he realized, as near as darn it, what they use is the solid rockets. So I've listened to some of his presentations, and it's quite funny because he ends it, he says, if you're going to build a dirigible, don't paint it with a solid rocket propellant. So, but that's just that anecdote. The reality is that hydrogen is, by nearly all accounts, the safest of fuels. You know, it's so light. If you have liquid hydrogen, it's up and away before it can do anything. Its radiation from it is very low. For example, if you were using hydrogen in an airplane, you crash the airplane, you either kill everybody, or there's some people that are there that are crawling away from the plane. And the tragedy is that some of those people burn from the radiation that comes off, you know, the big red fireball. It won't be as good for new movies, because movies in the future, when they're just hydrogen, there won't be the fireballs, they'll just be things.
They'll have to change their plot approach,
They'll have
I guess.
to change the
But
plan.
some of the non-fossil renewable energy sources that are out there, what role are they going to play, like wind, like solar energy?
They'll make a contribution. The problem with I call them conventional wisdoms, not conventional wisdoms, that we have today. For example, wind. Let's just stay with wind. First of all, we're using wind to supply electricity, and wind is intermittent. If you're having a heart operation, you don't want the electricity to go off. So, you know, you have to not just have the windmill, but you have to have spinning reserves in the background, which could be hydraulic or whatever. So the intermittency is really dangerous with that, and there's no possibility that we can provide enough energy. And moreover, all those are subsidized heavily by governments because they're the fad, the people want them. So I'm not dismissive of wind. I am pro-rationality, that's all. In other words, let's count and use the numbers and see how much it can provide and realize that it's heavily subsidized. And I think, and this will probably make some people have white knuckles, I think that nuclear power is probably the safest and the cleanest, is the safest and is the cleanest and probably one of the most reliables. And I think that we'll go to that in the future. Newfoundland doesn't have to right away because it's got hydraulic.
Yeah, let's talk about Newfoundland and Labrador specifically so far as producing hydrogen to make electricity and whatnot. What do we have available, especially in Labrador, which seems like it's, you know, the wealth of certainly hydro to drive production? What about Newfoundland and Labrador?
Well, I think Newfoundland and Labrador is wonderfully positioned for that. And the important thing is that remember that how you generate electricity is you have a shaft that's twisting like this, and you have an alternator on it that makes the electricity. But we can make the shaft just a little bit longer and put a DC generator on it, which can then go into electrolysis. The old high school experiment is that big. And by the way, all those technologies are in place. And what you can do when you don't need the electricity, because the electricity goes like this, the demand, but that thing can just continuously produce it, is you produce hydrogen when you're not needing the electricity. And I think particularly for Labrador, I think that the Churchill Falls, both Lower Churchill and perhaps more can be developed up Churchill, if you look to the future, Europe is really going this way. Europe wants a clean transportation system. They are developing hydrogen rapidly. I think that they would love to have hydrogen sourced from a clean source, which Labrador would be. And as I understand it, you can ship it by tanker. So I see a future. I would say, first of all, Labrador should develop that Churchill Falls, step one. And step
it's coming, we think.
Well, I hope so. I think that that's really good. And then you will produce electricity and in the future get ready to ship hydrogen.
Inside our last minute here, Doctor, you said nuclear very quickly there, and of course probably the safest, most benign form of energy in the world. First thing people think of, once again, is 3 Mile Island, and it explodes, and people can't make the distinction between weaponry and nuclear power, but it is very safe and efficient, maybe the way of the future.
I think it has to be the way of the future, unless civilization is determined to self-destruct, because this climate thing is really serious. And so
it's serious enough for you to call the book The Climate Catastrophe.
Yeah.
And it's also, I mean, it's getting rave reviews, and every time I Googled up one of the doctors who gave it a great review, these are people who have very eminent positions.
And so I was pleased with that. Let me one thing on 3 Mile Island. 3 Mile Island did not kill anybody. Correction, it didn't directly kill anybody. Right. No one died, no one even got sick. 3 Mile Island, the accident did indirectly kill them, because that was the thing that made the public demand no more nuclear power. And so they shut down nuclear power. What did they do? They put in coal, and coal kills a lot of people. And so we probably killed hundreds of people over the years by using coal instead of using nuke. And so the nuke was stopped because of 3 Mile Island.
I wish we had more time. Smelling Land, the hydrogen defense against climate catastrophe. Dr. Scott, pleasure to meet you, sir. Thanks for coming on the program.
My pleasure.
We'll try and get this book in the hands of one lucky viewer. Now let's go find Chrissy.